Okay, let's go over a few problems here. This is number 18 of 1.1. So f of x is graphed here, and we're supposed to evaluate f of 4. So that means the y height at x equal 4. So if we go to 4, the y height is 2. So this one's 2. And this one says the y height at some x is 4. And so they're wanting us to figure out what the x is. So if I go to 4 for a y height, it looks like the x is -3. So you got to read this as the y height at some x, or the y height at 4. The y height at some x is 4, so what is the x? Okay, that's 18. 46, some of you had some questions on. So on 46, the distance your big toe from the ground as you ride. So if I'm going to do this one, the distance the big toe is from the ground. So it's not going to hit this axis because it's saying the distance from the ground. So it's your toe's not going to go below 0. It's going to be somewhere above ground. So there'll be some distance, and that distance will go higher and lower and higher and lower. And it's going to make a curve that maybe looks like this as your toe goes around on the pedal from the top, bottom to the top, the bottom to the top. But there will always be some distance from the ground, and so there will always be some distance. Maybe it's 3 inches to 10 inches, but there'll be some kind of distance from the ground as time goes by. Your height above the water level in a swimming pool after you dive off of a high board. So some of you on this one said, okay, they're going to dive off a high board. So it might go up a little bit, but then they come down and you stopped here. Well, their distance above the water will actually go to a negative distance when they go into the water and then come out. So some of you didn't do that portion of it. And then the percentage of dates and names you'll remember for a history test, depending on how long you studied. Well, that one's pretty iffy. So if you don't study, well, you might even know some. So you might not start at 0, or you might say, I don't know any if I don't study. And then as you study more time, you may go remember more and more and more, or you may take some studying for a while before all of a sudden you start remembering them. Or you might be one that remembers a lot of them at first and then it gets less and less more. So they're hoping that you're writing some sort of increasing graph, but we're not sure which way to write that. Okay, and then 47. This is a good one, similar to the number 18. What is the y height at C? So L is the name of this point, but it has the coordinates C over and up T. So the coordinates here are C, T. And so what's the y height at C? It's T. And then what's the y height? At what x is the y height P? Here's P and for a y height, and at what x is that happening at? It's happening at A. Suppose the y height of B is Z. So if we go to B, we see that the y height is 0. So the y height at B is Z, so Z must equal 0. And then it says, what's the y height at Z? Well, if Z is 0, we're looking for the y height How high is this curve when x is 0? So we go up at 0 and we hit R. And what are the coordinates of L? I said that was CT, and at K, it's AP. And there's the answers to 47. 48. Dave leaves Padelford Hall and walks at a constant speed and reaches Gould 10 minutes later. So we're going to make a graph of that. So 10 minutes later, he starts at Padelford, which we're going to call 0, and the distance from Padelford Hall is 0, and you're going to get to Gould, which might be this distance. And so so it gets to be 2,400 feet, and he does it in 10 minutes, so he's just going to go up to the 2,400 feet at that if he's doing it constant. Now, Dave leaves Padelford Hall and walks at a constant speed. It takes him 6 minutes to reach halfway point. Then he gets confused and stops for a minute. Then he continues to Gould Hall at the same constant speed that he had when he originally left Padelford Hall. So he's still trying to get to the 2,400 feet. He goes for 6 minutes at a constant rate, gets confused for a minute. So this would be, what was it, 6 minutes. Then this is 1 more minute. So if that's 1, 2, 3, 4, 5, 6, then 1 more minute would not be very long. And then he goes at the same rate, so it's got to be the same slope, and gets there. Okay. Walks at a constant speed. It takes him 6 minutes to reach the halfway point. That was about halfway. So 2,400 and halfway in 6 minutes. So let's say that's 6 minutes. And a constant rate. Gets confused, stops for a minute to figure out where he's at. So if that's 6, 1, 2, 3, 4, 5, 6, 1 minute would be about there. Then it continues at twice the constant speed he originally had. So now it's got to be twice as steep. So something like this. Steeper than the other one. And we could probably figure out this one, but we're not going to worry about it. Okay? It would be another 3 minutes. So this would be 7. And then if he's going twice as fast to do half of it, it'll only take half as long. So it'd be 10 minutes. So we figured it out. Okay, that's it.